Thank you very much, and welcome. I was just told that I am actually, because of the transcription over there, explicitly forbidden to talk about Icelandic volcanoes. So this is going to be a very short talk, unfortunately. The great philosopher Steven Tyler once said, "There's something wrong with the world today. Something's wrong with our eyes. We're seeing things in a different way." And I think these innocent words perfectly describe how Internet Explorer was rendering websites in the past. But the same philosopher, in the same essay actually, also said, and I'm paraphrasing here, "Edge, yeah, 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 yeah." And what I think he meant to tell us with this was that as a Microsoft, we should build a new browser and call it Microsoft Edge. And in that sense, the works of Aerosmith and Steven Tyler have become somewhat of a modern-day Da Vinci Code for us. And what you will find is that much of Microsoft's recent product strategy is actually inspired by it. My name is Kai Jäger. I'm the CTO in residence at the Microsoft Ventures Accelerator here in Berlin. And like probably many of you, I also was a web developer in the early 2000s. And because of that, my relationship with Internet Explorer has always been somewhat complicated. Like probably many of you, I've written countless hacks, written terrible code just to make sure a website also worked in Internet Explorer that was already working perfectly everywhere else. And like many of you, I've hated it. I thought it was the worst experience, and that's not a good place to be in. Now, when I started working for Microsoft, I was an Internet Explorer evangelist for a little while. And I would speak at conferences like this. I would talk about Internet Explorer. But when my family asked me what my job was, I would usually say that I was into drug trafficking because that raised fewer questions. But you know that things have changed quite a bit. But still, things are still on some fundamental level very wrong. If you go on GitHub and you search for IE sucks, you will actually find that it returns 344,000 results. And when I saw that, I was shocked. I didn't know what to do with this information. And at one point, I actually thought, maybe I'm looking at this all wrong, because IE is also the top-level domain for Ireland. So maybe, just maybe, what these people are trying to say is that they're just not very big fans of the band U2. And I have to admit that at some point, I also felt that Bono was a bit pretentious. But then if you search GitHub for Internet Explorer sucks, you still get about 54,000 results. And I like the second one here that says, "Stop using this when Internet Explorer no longer sucks." So, and there's really only one conclusion one can draw from this, and this is that, by and large, developers are not completely satisfied with the experience of writing code for Internet Explorer. And this is a bad position to be in. And I'm not going to make a bunch of excuses, because really there are not very good excuses for this, but I'm going to at least attempt somewhat of an explanation. Internet Explorer is, in recent versions, a lot more standards compliant. If you've used IE 11, you will find that it's actually a pretty good browser. But there has always been a lot of baggage that we've been carrying around with us because of our legacy. And Internet Explorer actually has a 20-year legacy. IE 1 actually came out in 1995. And this baggage is a big problem, because we're carrying around different document modes. And let me really quickly explain what these are. When we talk to the different developers out there, there's really like two groups. One is the bigger group, and I think it is very well represented here today, of just your average web developer, and they're pushing us to say, look, you have to build a more standards-compliant browser. You have to release updates more frequently, because we don't want to be stuck with these outdated standards and stuff. On the other hand, our enterprise customers are actually pressuring us to not change anything. So these are very conflicting messages. And the reason why they're doing that, it's not because they're mean or because they're behind the times. It's because they have investments in these intranets and internal websites and internal tools that they've spent millions of dollars on building, and we would break all of these sites if we didn't support the broken implementations of web standards that we had in old browsers. Now, the way we dealt with this was we actually introduced something called document mode. So you can actually force IE11 to render a website as if it were IE8. And we do that with IE9, IE10, and even with older versions. This may seem like a good solution, but what that actually means is that instead of maintaining just one browser, we're actually maintaining 7 or 8 browsers. And all of this baggage really slows us down. And when we were thinking about a new version of our browser, we figured that the only way we could build a really useful, powerful browser was to drop all of that baggage. And so what we did was actually a very drastic step. We forked Internet Explorer. And what that means is we actually took the Trident rendering engine, which powers IE, we took Chakra, which is our JavaScript implementation, we copied and pasted the code into a new repository and basically started over. Now, we still have Internet Explorer. If you go on Windows 10 today, you will find that it has IE11 built in, but we only support that so our enterprise customers can still use their intranets and their internal tools. For all other purposes, Edge is the new Microsoft browser, and it is also the default browser in Windows 10. So when we set out to build Edge, we had like one big guiding principle, and this guiding principle was we wanted the web to just work for everybody. And everybody, that includes, of course, the users of the browser, but it also includes all of you, the web developers. And what we mean by we want it to just work is we want you to no longer have to write code that is specific to Internet Explorer or to Edge. We want you to write code once without vendor-specific modifications, and we want this to work consistently across Google Chrome, Safari, Firefox, and Edge. And in order to make that happen, we had to do a couple things. One thing is we really had to up our game in terms of web standard support, and we've been working on that for a while, but we've really upped our game with Edge. But we're also implementing forward-looking standards, and what I mean by that is these are standards that are not officially standardized yet. They're part of like a W3C working draft, but we're picking and choosing the ones that are already being used in the web, and we're implementing those as well. We are also adding support for pseudo standards, and I'm going to give you an example of that. But what I mean by that is these are sort of things that a lot of browsers implement that are not actually formally standardized. And we're adding support for that just to make sure that the web works consistently for everybody. And lastly, and this was sort of the most satisfying part of it, we ripped out all of the baggage of Internet Explorer. So we have no more backwards compatibility. There's not IE7 mode in Edge, none of that. In fact, when we were done with building the first version of Edge, we had actually removed some 220,000 unique lines of code from the Internet Explorer code base. And this included 6 document modes. I'm talking about IE8 mode, IE9 mode, but we also removed some 300 APIs. And just to give you some examples of this, we removed ActiveX support, we removed browser helper objects, we removed VB script support, but we even removed small things like attach events. So you probably know, add event listener, we had a non-standard version of that. That is gone. So we are really starting with a clean slate here. There is no Microsoft proprietary extensions in this anymore. So it's a really, really clean browser from the start. Thank you very much. But at the same time, we also added 300,000 new lines of code. And these 300,000 new lines of code include 55 new web standards that we're supporting, but also 4,200 interoperability fixes. And what I mean by this is these are tiny things and big things. So in terms of tiny things, stuff like where Chrome has a slightly different interpretation of a web standard, and sort of we were trying to find a common ground where the specifications are not as clear as they should be. So we wanted to make sure that you never actually have to worry about Edge doing a thing of its own. But when we set out to figure out what kind of features do we actually want to implement in Edge and what kind of things do we need to fix, we found that that was actually very, very hard. Because over the years, people have found very, very clever ways of making websites work in IE, and one of those ways included serving different content to Internet Explorer. So oftentimes, when a website would look really fancy and use a lot of CSS3 in Chrome, we would actually get a very dumbed-down version that was CSS2 with some IE-specific quirks. And this is, used to be the reality. I know we are in part, or actually completely to blame for that. But the problem is, if you want to build a better browser, you actually need to get the same content as everybody else so you can figure out what's wrong with your implementation. And one of the key culprits in this is the user agent string. And the user agent string is actually supposed to identify a browser, but the truth is the user agent string is really a bag of lies. And I'm going to illustrate this for you. So these are the user agent strings of some of the common browsers. And what you will find is that all browsers identify themselves as Mozilla 5.0. You know what that is? That is actually Netscape Navigator. So every browser out there says, I'm Netscape Navigator. But what you also will find, for example, with Chrome is that it says it's KHTML, which I think is Conqueror on Linux, and it's also like Gecko, which is the Firefox rendering engine. So all user agent strings actually lie about what they are. And we are no exception here. We're actually, I think now, the worst of it all, but it was actually necessary to make sure we get the same content as everybody else. So we are happily announcing that we are both Apple WebKit, KHTML, Gecko, Chrome, and Safari. And I know this is madness, and we're not very happy about this, but in the end, it is for the greater good. But as a quick side note, I want to encourage you that looking forward, please do not use user agent sniffing anymore. So if you have code on your server, like regular expressions that say, if this is that browser, I'm going to serve a different content, don't do that. Because that is always going to break along the line when new browsers are introduced. You're still going to serve them old content, even though they have better capabilities. So instead, use feature detection where possible. Again, I know it's in part our fault, but we want to redeem ourselves, and we need your help to do that. Now, what we then did is we set out to find the things on the web that broke our browser. One thing we did is we just looked at the top 1,000 most popular websites. We opened them up in an early build of Edge, and we looked at what didn't work, and we fixed it, essentially. Pretty simple. What we also did is we took the Bing crawler, the Bing web crawler, and we used it, we instrumented it to collect information for us from millions of websites. So what features do they use? Like, what extensions do they use? What set of web standards do they use? But also, we loaded them up in like a headless version of the Edge rendering engine, and we collected error information to figure out where we did not do things right. And we took all of that information, and we made some 4,000 optimizations because of that, or 4,000 changes because of that. And I want to give you some pretty interesting examples because of that, and you're going to find that they're a bit different probably than what you might have expected. So on the left, you see a screenshot of Internet Explorer 11. On the right, you see a screenshot of Edge of the same page of Hawaiian Airlines. And on the right, what you will find is that there's a bunch of icons that render correctly. On the left, they're not rendered at all. And the reason why they're not rendered at all is because we are, for once, doing something right. We actually adhere more strictly to the standard that applies to this than WebKit does. Firefox actually has the same problem. What the standard says is that if you are serving a font file, and this is actually a web font, then you have to honor the cross-origin and installable headers of that file. WebKit actually ignores this, and this is why this works. So we have chosen, I know this sounds crazy, to make sure that our mobile browser version renders this the same way as the mobile browsers on iPhone, iPad, and Android. So we've actually implemented the standard the same way that Chrome and Safari does. So this just works. You don't have to change anything. This will just continue to work in the future. Here's another weird example. So this is the Groupon mobile website. And as you can see, there's like a minor difference in the way these are rendered. And when we looked at this, we found that Groupon actually uses a CSS attribute called WebKit Appearance. Now, WebKit Appearance is not a web standard. It is actually an invention of Apple, and it is not standardized by the W3C. But we found that actually a lot of mobile sites use WebKit Appearance. And so we decided to just support it, and we actually support it with the WebKit vendor prefix. So you don't have to touch your code at all. It will just work. Now, speaking of vendor prefixes, we found another interesting thing. So let me first say, what we now do is if we find a prefix CSS attribute or a CSS selector, and there is not an unprefixed version and not a version that uses the MS, the Microsoft-specific prefix, we will actually consider the other prefixed versions. So we will actually use WebKit prefixes if necessary. And we did that because, thank you. Now, you can probably have like a divided opinion about vendor prefixing. But what actually is happening with vendor prefixes is that a lot of websites just use the WebKit prefix. Even though we have support for much of CSS3, we often don't get to render it because people don't use the Microsoft prefix. So instead, we're now considering the WebKit prefix, but we did one more. So on this side, you see a subtle change in the use of gradients. And what we found was that when Apple first introduced the gradient CSS syntax, before it was standardized, the syntax was actually different from what was ultimately standardized. So there's actually two versions of gradient syntaxes. And a lot of websites still use and only use the obsolete Apple version of it. So we've actually decided to support that as well, just to make sure that websites render consistently. Now, let me make this absolutely clear. I'm not encouraging you at all to use obsolete CSS syntax, and I'm not encouraging you to use vendor prefixes where there's an unprefixed version. But just to make sure that everything renders the same across all browsers, we've actually went to these lengths to make sure that it all works. But besides these many, many thousands of small fixes like this, we've also added a ton of new features, stuff like web audio support, pointer events, CSS filters, image source sets, ECMAScript 2015, I'm going to talk about this in a second, HTTP2, SVG for an object, OpenRTC, SIMD extension, ASM.js support. And on top of that, of course, we support everything we've also already supported with IE 11 and the versions before, stuff like WebGL, Speedy, WebCrypto, File API, and so forth. Now, when we decided to implement all these features, we also knew that we needed a new update strategy. You probably know, and this is one of the main pain points with Internet Explorer, that it's updated with the operating system. So for us to introduce new features into IE, we actually had to wait for like a service pack or a major release of the operating system. With Edge, we've actually adopted the same update model that you will find in Chrome and Firefox today. So we will actually update Edge independently of the operating system, and we will do feature updates along the way. So it is the same evergreen version of Edge as you would expect with Chrome. We also don't talk about Edge in a specific version, so it's just Edge, and we will keep updating it as new features are implemented, which I think is super duper important for this. Now, people still obviously ask us, look, when are you going to implement feature X? When are you going to implement feature Y? And obviously, even though we are a big company and we have a lot of engineers, we have limited engineering resources still. We can't implement everything at once. So obviously, we prioritize, and we've decided to be extremely open about this. And I'm going to show you how we are doing this. So this is a site. It's called modern.ie. You can go there now, and we have a page here that says platform status. And on this list, we first of all show you all of the different web standards that we are currently tracking, and you can see the state of their implementation. And you can see that some of them are in preview, so we have a preview build of Internet Explorer that's not stable yet. You can download that, and you see some of the features in there. We have some that are in development, but we also have some under consideration, where we sort of think about, look, this might make sense to implement it. We have to prioritize, but eventually we will implement this stuff. And the other thing is, we actually want to have an open discourse with you about which features are important and which ones are not. So this is User Voice, which is our customer feedback portal. And you can see somebody here asks that we should support OGV and OGG video and audio formats. And here's a comment from somebody on the engineering team saying, look, it's currently under consideration. So we're looking at it, and we're deciding on whether we want to implement this. So we want to be a lot more transparent about this, and you can actually see the status of all of the web standard support right there. Now, this is a JavaScript conference. I'm fully aware of this, and so I should probably talk a little bit about JavaScript. And we've also done a lot of work around JavaScript in Edge. We've also done a lot of work in previous versions of IE, but there's some really, really cool and powerful new features in Edge. Now, our JavaScript engine is called Chakra, and that is a just-in-time compiler like you have it in other browsers. We've done a ton of performance improvements to this, because this is really where most developers get the most value out of, because when your applications run faster, I think everybody wins. But we've also added stuff like SIMD support. I'm going to talk about this. We've added ASM.js support, and we've added massive ECMAScript 2015 support, which I think is really cool, and I'm going to show you a demo of that. But let me first talk a little bit about how Chakra works, our JavaScript execution engine. So like any other JavaScript engine, when we see a bunch of JavaScript on your page, we parse it, we turn it into an abstract syntax tree, and then we compile it into bytecode. And what we then do is we have a bytecode interpreter that runs the JavaScript for a bit. But while we run the JavaScript, we collect profiling information on stuff like how often is a function called, what types does a call side see. And after a while, we actually pass that profiling information along with the bytecode to a just-in-time compiler, to an optimizing just-in-time compiler. Now, what's always been sort of semi-unique about Chakra is that we actually just-in-time compile on a separate thread. So we are not blocking the UI thread or the main thread while we are doing just-in-time compilation. This is a really cool feature, and it allows us to do more aggressive optimization because we're not stalling the UI while we are compiling. Now, one small downside of having an aggressive optimizing compiler is that it takes longer before you break out of the interpreter and start actually running machine code. So what we've done in Edge is we've actually implemented a second just-in-time compiler that is not as optimizing. So it's much, much faster. So what we can actually do is, after running your bytecode for a very short amount of time, we will actually instantly just-in-time compile it using the simple JIT, and then after a while, we will send it to the optimizing JIT if we feel that that's going to make it faster. So you're going to have better performance right away when you load the page, but we've also done another thing. We've actually allowed the just-in-time compiler to use more than one thread. So if you have a multi-core CPU, which even mobile phones nowadays have, you can actually make better use of those CPU cores, and that's going to give you even better performance. So really cool optimizations. What we've also done, and this is probably the one thing that struck me the most as really unexpected, is we actually found that minifying JavaScript has a negative impact on performance because the patterns that minifiers generate do not allow the optimizing compiler to make as many assumptions about the code as unminified code. So we analyzed this, and we found there were some tweaks that we could do to make this much, much faster. And so we're running minified code now almost at the same performance as unminified code, which I think is nice. We also improved polymorphic inline caching. That is when you optimize variables, for example, for different data types, so you don't have to do lookups every time. And we implemented a parallel garbage collector, which I think is also a great feature. You probably all know that when you have animation on a site or when you're building a game, you sometimes have stutter during animations. So your frames per second drop from 60s to something else, to something below that, and then go back up to 60. And this is an effect that is typically caused by garbage collection pauses. And by running the garbage collection in parallel on multiple threads, we can actually reduce these pauses significantly and sort of eliminate the stutter that you will see during animation, which is, of course, important for games and that sort of stuff. Now, everybody likes benchmarks, but I want you to take these with a grain of salt, because the performance of a browser is much more than just sort of winning at some synthetic benchmarks. It's really about DOM performance, about rendering, about JavaScript, and many factors. So this does not mean Edge is the fastest browser in the world, but we're still very happy that we're actually very good in these benchmarks. So actually, Edge stable currently beats Apple Jetstream, Google Octane, and in SunSpider, both Chrome stable and Firefox stable, which I know is not going to stay like this for very long, and I think that's actually a good thing. So I want Chrome to actually beat us on this, because this is, I think, the only browser war we can actually all get behind is the war for better JavaScript performance, because that is a war where we all win. So I say bring it on. So one thing I want to talk about is SIMD, or single instruction multiple data. And this is a very technical thing, but I think it's a very cool thing that this is actually making its way into browsers. So when you run an add instruction on a CPU, typically what you do is you give it 2 parameters, you give it a 5 and a 7, and it's going to calculate the sum of 5 and 7. Now, what SIMD is, these are CPU instructions that can operate on vectors. So instead of just giving them 2 values, you can actually give an SIMD operation 8 values, for example. And the SIMD instruction is actually going to compute the result of that in one single instruction, and often in very few cycles. This is critical for vector mathematics, for 3D graphics, that sort of stuff. And it has a huge impact on performance, especially with games, graphics-heavy applications, and so forth. Now, we've worked with Intel, and this is also going into other browsers, to implement SIMD extensions into Edge, and I'm going to show you a very quick demo of this. This is a demo built by Intel, actually. And when I start this, you can see that this is running at about 20 frames per second, and it zooms in on this fractal, and you're going to see that the performance is sort of degrading as I'm zooming in. Now, when I enable SIMD or disable it again, you can see that the performance increases significantly, because all the mathematical operations it's performing, it can actually do at almost 4 times the speed often. So this is going to be extremely helpful in writing scalable and fast games in JavaScript and graphics-heavy applications. Now, the other thing we're implementing with Edge, and both of these are, by the way, experimental, so they're behind a flag, but we are also adding asm.js support, as you also already have it in Firefox. For those of you who are not familiar with it, asm.js is a subset of JavaScript that is a compiled target language for mscripten, and it's basically how you can run C and C++ applications in a JavaScript environment. Now, what we can actually do, because asm.js has some very strict rules, we can actually much more aggressively optimize it than typical JavaScript code. But we didn't do that in the past. We just treated it as any other JavaScript code. Now we have a special code path for it, so we can actually compile it differently and run it at almost native performance. I don't have a demo for it. I just want to show you. This is also new in Edge. You can actually go to About Flags, and then if you scroll down, there's actually a setting for JavaScript to enable experimental features and to enable asm.js. So you can actually use that in your browser in the insider build right now, which I think is pretty cool. And of course, I also want to talk a little bit about ECMAScript 2015. Just a quick show of hands, who here is excited about ECMAScript 2015? Awesome, excellent. So ECMAScript 2015 is a really, really cool thing. Since I'm running a bit out of time, I'm going to show you this very, very briefly. So this is your typical JavaScript code as you would write it today. And you can see, for example, in this case, there's an anonymous function. And you see the syntax for this is clunky. You have this problem where if you want to use this inside of an anonymous function, it often doesn't refer to what you think it refers to. In ECMAScript 2015, you can write classes, and you have this arrow syntax, which is a much nicer way of specifying anonymous functions. There's a ton of other stuff that I can't get into. I just want to show you this real quick. We actually have a ton of support for ES 2015 in Edge. You can actually see here that Edge 13, which is the latest version of it, has 80% ECMAScript 2015 support. We're ahead of all of the other browsers. But what I'm going to say, and I'm actually going to skip, I think, to another slide just to save some time. Basically, what we want to do is we don't want to be the only one or the first one to implement a specific standard, because that is essentially useless. We want the web to work consistently across all browsers. And what that implies is that we also need to make sure that we all work together as browser vendors to make that happen. So one thing we did with ECMAScript 2015, because we already had such big support for it, is we are actually sharing our test suite for ES 2015 with everybody. So everybody writing an ES 2015 implementation can actually run our test suite to make sure that their implementation adheres to the standard, which I think is also quite new from Microsoft. So I'm going to leave you. I actually wanted to show you a bunch of things, but I'm going to skip ahead of this. So there were, OK, let me show you at least this one real quick. So over the years, IE has given us a ton of laughs, and I think it's time to put an end to this and to start working with a serious browser. So thank you very much. Go to Dev Modern IE.
Thank you. That was a great talk, thank you. Next up, we'll have a talk about